In this video, we will solve four classic chemistry problems, which particularly involves preparation of standard solutions from hydrated salts. So let's solve this problem step by step. For number one, describe the preparation of 2 liters of 0.108 molar BaCl2 from BaCl2 to H2O with a molar mass 244.3 grams per mole. So if you notice in this question, we were asked to describe. Typically, this question requires us to explain our answer. Okay? It does not want just the quantified value. It wants us to explain how to prepare in this case. So, as we can see in the problem, we were given the hydrated salt form. Okay, hydrated salt. But we were asked how we prepared the non-hydrated form. So this is a typical question for general chemistry and analytical chemistry topics. But first, let us discuss why is this the case. Okay, so in general, solutes particularly, solutes, so in this case, BaCl2 particularly starts in its crystallized form. When we hear crystallized form, it is usually in solid state, which we prefer when we want to prepare solutions efficiently. So the solid form are crystallized due to its process, which we call dissolution. Okay, prepared from dissolution. Okay, and these are usually the most stable form. This hydrated salt form of BaCl2 is usually the most stable form and thus preferred when making a reagent, okay? Or preferred as a reagent, stable, okay? Preferred form as a reagent. That's why in the lab, when we prepare solutions, we usually start with its hydrated salt form. Okay, hydrated salt form is indicated in the label of the chemical you use. And then you will solve for the molarity or the concentration of its non-hydrated form. So this is usually explained through stoichiometric coefficients, okay, which we will explain later on. For this problem, let's start with the concentration flow. We want to know how much of BaCl2 to H2O were used to prepare 0.108 molar BaCl2. Okay, so we want to find how much of this. How much? So this would be in grams using its molar mass. So through dimensional analysis, we can determine the mass of BaCl2 to H2O. Okay, so let's start with the concentration, which is 0.108 molar BaCl2. So that's mole per liter, right? Because molar is mole per liter. Okay, so this is mole BaCl2. In order to cancel the liter, we use this given volume. We have 2 liters, okay, 2 liters. So now we are left with mole of BaCl2. Okay. This time, we will use stoichiometric coefficients. So 1 mole of BaCl2, how much mole of dehydrated salt? It's still 1 mole. Okay, okay, let's see why. So when you are talking about BaCl2 here, we want to know how much of this is in the hydrated salt form. Okay, so this is what we are looking for. So there is only one BaCl2 in BaCl2 2H2O. Okay, for instance, we want to know the water, not BaCl2. Okay, in 1 mole of BaCl2 2H2O, how much water are there? So 2 mole of H2O, because we are looking at the H2O and there are two here. Okay, so another example is here. For instance, we want to know how much chlorine in BaCl2. Okay, so 1 mole BaCl2, there are 2 moles of Cl. Okay, because there are two Cl in BaCl2. Okay, so uh, that's how coefficient works in hydrated salts. So basically, this is just a 1-to-1 ratio, and most hydrated salt uh, calculation are just 1-to-1. Okay, but you can use dimensional analysis to confirm this one. Okay, now we can cancel the mole of BaCl2. Now we can focus on the hydrated salt form. So 1 mole of BaCl2 2H2O, using the molar mass, we have 244.3 grams. Okay, now we can cancel the mole of BaCl2 2H2O, and we are left with a mass. Okay, solving, this would be 52.76, or 52, because this one is 877 grams. Okay, I just round it off. So this is the mass that you should weigh in order to prepare 2 liters of 0.108 BaCl2. Okay, this is BaCl2 2H2O. So let's explain, because the question wants us to explain, it wants us to describe the preparation. So let's answer this through method view. So first, weigh 52.77 grams of BaCl2 to H2O. So that is the first step. Okay. Then next, place the solute in, so the solute, we are talking about BaCl2 to H2O. Place the solute in a 2000 ml V flask. Okay, so 2000 ml is 2 liter. Okay, 2000 ml or 2 liter flask. After that, you will dilute to mark. Then we prepared 0.108 molar BaCl2. Okay, that's how easy it is. Okay, so you can explain this through a sentence form, but this one is easier to see through method view. Okay, that's how you prepare 0.108 molar BaCl2. Okay, so next question. Okay, you can answer this one yourself. You can just pause the video or you can follow along. Okay, describe the preparation of 1.50 liter of 0.250 molar magnesium sulfate using magnesium sulfate heptahydrate. Okay, that's how you read it. For MgSO47H2O with a molar mass 246.67 grams per mole. So magnesium sulfate here is just basically Mg SO4. Okay, okay. Let's solve this step by step. Okay, as usual, let's start from the concentration. So the given concentration is 0.250 molar magnesium sulfate, so that's MgSO4. Then molar, that's mole per liter, okay? Okay, let's do mole per liter here so that you won't be confused. Okay, then let's use the given volume. So this is the volume we have prepared. So 1.5 liters. Okay, then we can cancel. We're left with mole MgSO4. So 1 mole of MgSO4, how many moles of the uh, hydrated salt form? That would be 1 mole as well. So typically this is always 1-to-1 ratio. Okay. Then through using the molar mass, we can calculate for the grams needed to weigh for the hydrated sulfur or magnesium sulfate hydrate. Okay, so cancel this. We're left with grams, and that is 92.50 grams. Uh, Magnesium sulfate heptahydrate. So most of the time, molar mass is not given. So that would be a challenge because this is particularly an easy question, right? So sometimes this is not given. You need to use your periodic table. And oftentimes, students um, get confused what molar mass they should use. Some students will use the magnesium sulfate, okay? And some students will use this. So this is the proper way. You should use the molar mass of the hydrated salt form, not the magnesium sulfate only. Okay, you should note that. Because sometimes when the molar mass is not given, you may use this one, magnesium sulfate, rather than the magnesium sulfate heptahydrate. Then we can explain how to prepare this 0.250 molar magnesium sulfate. Okay, so first you should weigh 92.50 grams of magnesium sulfate heptahydrate. Then after that, place in a 1.5 liter volumetric flask or 1500 ml. Either case, the same thing. Then, after placing that, dilute to mark. Okay, dilute to mark. Then, you produce 0.250 molar MgSO4. Okay, so that's how you prepare magnesium sulfate from magnesium sulfate heptahydrate. Okay, next, describe the preparation of 500 ml of 0.150 molar copper 2 sulfate from copper sulfate pentahydrate with the molar mass 249.68 grams per mole. Okay, most students get confused to this, especially when they don't know how to name yet a specific compound. So copper 2 sulfate is just CuSO4. So the 2 there, so Cu, this is actually Cu2 plus and SO4 2 minus. When we are talking about the 2 plus, so the charge of the copper. Okay, so this can be explained in a chemical compound naming. Okay, so but in this video, let's focus on the preparation. So let's start with the molarity or the concentration, which is 0.150 molar copper sulfate. Okay. Note that molar is mole per liter. Okay. Let's just put it in mole per liter. So we used 500 ml. So 500 ml is basically 0.500 liters. Okay, then that's just through conversion. Okay, next would be the mole. So 1 mole of CuSO4 is still what? 1 mole. Still 1 mole. 1 mole CuSO4 5H. Okay. Then using the molar mass given, we have 249.68 grams mole of CuSO4 5H2O. Then solving through your calculator, this is 18.73 grams. Okay, so this is CuSO4 5H. To describe the preparation of this solution, let's start with what? Weigh 18.73 grams of copper sulfate 5H2O. Then place in a 500 ml volumetric flask. Then dilute to mark. Then you prepared 0.150 molar CuSO4 or copper 2 sulfate. So that's just it. Okay, the last question. Describe the preparation of 750 ml of 0.0750 molar sodium carbonate using sodium carbonate 10H2O with a molar mass 286.14 grams per mole. Sodium carbonate is just Na2CO3. Okay. So, as usual, let's start with the given concentration, which is 0.0750 mole of sodium carbonate Na2CO3 over liter, because that's in molarity. Then, let's use the given volume. So 750 ml is simply 0.750 liters. Okay, so conversion. Okay. 1000 ml is 1 liter. So this is that. Okay. Times, then we can cancel liters. Then we're left with mole of Na2CO3. So 1 mole of sodium carbonate is still 1 mole of dehydrated salt form. So Na2CO3 and H2O. Okay. Then 1 mole of dehydrated salt form has a molar mass of 286. Okay, I'm getting a lot of space here. Okay. So next, solving this, we will have 16.095 or just 16.10 grams. Okay, I just round it up. So this is 16.10 grams Na2CO3 10H2O. Okay, now let's determine or let's describe how to prepare this solution. So let's weigh 16.10 grams Na2CO3 10H2. Then place it in a what 750 ml volumetric flask. Dilute to mark. Then we prepared 0.0750 molar sodium carbonate. Okay, so that's easy. So that's all. Thank you for watching the video and I hope this helps out. Please like and subscribe. Thank you.